In this video, I'll be solving the 9th problem of IOQM 2024. So we were asked to consider the grid of points X, and we say a pair of points is a knight move pair if C is equals to A plus or minus 2 and D is equals to plus or minus 1, or C is equals to A plus or minus 1 and D is equals to B plus or minus 2. And we need to find the number of knight move pairs in X. So first of all, like if we are given like any m cross n grid of lattice points, so here in this case, like it's going from 0 to 4. So basically the grid is m is equals to 5 and n is equals to 5. So it's a 5 cross 5 grid, and we wanted to count the directed knight moves in a 5 cross 5 grid of lattice points. So knight can move in eight different ways. So, and how can we say that? So if we consider like the C and D value, like for this A, so basically it's plus or minus 2 comma plus or minus 1, or it is plus or minus 1 comma plus or minus 2. So that means horizontal 2 vertical 1 type will be 4, and horizontal 1 vertical 2 type will be another 4. So here we are getting 4 and here we are getting 4. And here how are we getting 4? Here we are getting 4 by multiplication principle. And here we are getting 4 plus 4, which is 8. So here we are using addition law in order to get this 8. So a knight can move in 8 ways, and counting them separately we are getting 8. So now if we have to suppose we want to make a move like the first case, that is plus or minus 2 comma plus or minus 1. So in that case, like from x comma y, we'll be going to x plus 2 comma y plus 1. Now we also have to stay in the grid, right? Our knight should stay in the grid. So for our knight to stay in the grid, so our x must satisfy this thing. So 0 less than or equal to x less than or equal to m minus 3, because x plus 2, the horizontal move that you are doing, so that should be less than or equal to m minus 1. So that's why our x should be less than or equal to m minus 3. And similarly, y must be less than or equal to n minus 2, because y plus 1 must be, since y plus 1 must be less than or equal to n minus 1. Because if we, like, why am I using n minus 1 here? Because like we're starting with 0 here. So 0 to 4 we are having. So though it is 5 cross 5 grid, so the points wise it is until 4, like 4 is the maximum. So that means, and there are like 4 variants. For plus or minus 2 comma plus or minus 1, there are 4 variants. What are those variants? Like right plus up, or right plus down, or left plus up, or left plus down. So there are 4 variants. So that means 4 times 0 to m minus 3 we have m minus 2 solutions, and 0 to n minus 2 we have n minus 1 solutions. So basically in this case, like plus or minus 2 plus or minus 1, we have 4 times m minus 2 into n minus 1. In the similar way, plus or minus 1 comma plus or minus 2 moves, you will have x 0 less than or equal to x less than or equal to m minus 2, and 0 less than or equal to y less than or equal to n minus 3. So that gives us 4 times m minus 1 into n minus 2 moves. So basically a knight, so knight moves will be in an m cross n grid, number of directed knight moves will be 4 times m minus 1 into n minus 2 plus 4 times m minus 2 into n minus 1. So now like we are asked for a, now each knight has a partner. So basically suppose like if A to B, so this will also have a partner like B to A. So we want unordered pairs. So unordered pairs will be 4 times m minus 1 into m minus 2 plus 4 times m minus 2 into n minus 1 by 2. So they will be like the number of unordered pairs, because ultimately like we're interested in the knight moves. Now every knight move, like if A is going from B, A is going to B, that will also have another partner where B is going to A. So they both are like ordered pairs, but like we want unordered pairs, A comma B. So basically we just have to divide it by 2. So here our grid is M is equals to 5. Yes, M is equals to 5, N is equals to 5 in our question. So 4 times 4 times 3 plus 4 times 3 times 4 whole divided by 2. So that is 48 plus 48 by 2, which is 48. So there will be 48 knight moves in a 5 cross 5 grid. And I have also derived the generalized formula here, so which you can use it for the future, like any future questions. So that's it for this video. I'll stop it here and we'll meet in the next video.